Hi class, this is course 3, lesson 21, distributive property and order of operations. Let's start with distributive property. The distributive property is also called the distributive property of multiplication over addition. Okay, so you can see why maybe we shortened the property to just distributive property, but it is important to note that you are going to multiply over addition. I just want to make sure that you know that this could also be subtraction. In the math world, we talk about subtraction being really just adding the opposite. So it is addition or subtraction. Distributive property will look like this, or when you can use it, your problem or your expression will look like this. You will have a number outside a set of parentheses. When you see problems like this, there are two ways to simplify, especially if there are numbers only on the inside. First way to simplify would be to simplify inside the parentheses first. 4 plus 3 would be 7. So then you could multiply 2 times 7 and your answer is 14. Option 2, the distributive property, remember we are going to multiply over that addition. So what I do is draw little arrows to tell me that I am going to distribute or give that 2, that factor of 2, to both of those terms. So I am going to take 2 times 4 and add it to 2 times 3. What is 2 times 4? That is 8, and what is 2 times 3? That is 6. 8 plus 6 is 14. Okay, so you can see we get the same answer. Now you might say, well, that's fine. Why wouldn't I just do option 1? Well, not always are you going to have numbers in there. Inside the parentheses, you're going to get things that look like this. A plus B. You cannot add A and B together until you know what those values are. So when we have variables inside the parentheses or outside the parentheses, distributive property works really well for us. So there are two things we can do with distributive property. We can expand and factor. Okay, and we're going to do an example of each here, and then we're going to do a couple other problems, and you'll get an opportunity to try as well. So expanding means to actually distribute the factor to the terms. Okay, so you'll draw the arrows and multiply that 3 times the A and multiply the 3 times the B. That's it. When you factor, you undo the distribution of the factor to the terms. In other words, you would divide it. And when you're doing that, you want to find the GCF, the greatest common factor of both terms. That way you have it factored completely. So let's look at this first example. We have bx plus by. So what could we divide both terms by? What is the greatest common factor? Well, it's b, right? There's a b here and a b there. We don't know what it is, but whatever it is multiplied in both of those terms. So we'll put the b on the outside of the parentheses and then divide both of these terms by that b. When I divide bx by b, I get just x, and when I divide by by b, I get just y. And you can check this because if you were to distribute that b in, if we were to go up here and draw those arrows, we would get b times x plus b times y, which is what we started with. The second example, we need to find the greatest common factor between 6a and 21b. Greatest common factor, I think, is 3. So I'm going to put a 3 outside here and divide both of those by 3. So 6a divided by 3 would be 2a minus, what is 21b divided by 3? Would be 7b. And you can check to see if you have factored it correctly when you have numbers, coefficients in here, or variables. If the variables are the same, You did not factor it out completely. If your numbers have factors that are the same other than 1, you did not factor completely. And again, I can check. I can say, does 3 times 2a give me 6a? Yep. And does 3 times negative 7b give me negative 21b? Yes. Okay. I want you to try. So take a look at these. You're going to expand the first one, factor the second one, pause the video. When you're ready to do it, when you have that worked out, press resume and you'll see the answers over here on the right side. Okay, so the first one, when you multiply 2 times x and 2 times negative 8, you get 2x minus 16. And the second one, your greatest common factor should have been 3. 3 times 4a gives you 12a, and 3 times 5b gives you 15b. So hopefully that's what you have. If not, please let me know. The next thing that we needed to talk about was the order of operations. Those are rules for simplifying expressions with more than one operation. We start with parentheses. Those are grouping symbols, brackets, braces, fraction bar, absolute value. Anything that puts terms together other than addition, subtraction, multiplication, and division. Next comes exponents and roots. Then we multiply and divide in order from left to right. Then we add and subtract in order from left to right. Now these, we need to make sure that you understand that it is from left to right. It is not that we do multiplication first, then we do division. We do whichever one comes first when we work through the problem from left to right. Same with addition and subtraction. We can also remember it by saying PEMDAS or please excuse my dear Aunt Sally. And the PEMDAS refers to parentheses, exponents, multiplication, division, add, and subtract. You need to make sure that you are showing your work. Okay, and we're going to demonstrate that here. The example 4 plus the quantity of 11 minus 3 squared times 2 cubed. Starting with parentheses, so do we have parentheses? Yes, we do, and you might find it useful to underline. Then I'm going to write down what is around it because we need to simplify this first. So I would have 11 minus 3 squared. When you're in parentheses, then you still work the order of operations. So it'd be parentheses. Okay, we're in there. Then exponents and roots come next. So we would do this 3 squared, which 3 times 3 is 9. Okay? That's all I could do, that step. Then I go back and I say simplify in parentheses. So I can simplify inside here now. Do I have exponents and roots? No. Do I have multiplication and division? No. Do I have addition or subtraction? Yes. So I'm going to simplify 11 minus 9. 4 plus 2 times 2 cubed. Okay, now I didn't leave myself enough room, so I'm going to go up here. Now I start over. Do I have parentheses? No. Do I have exponents and roots? Yes. I need to simplify this first. So I have 4 plus 2 times, what is 2 cubed? 2 cubed is 2 times 2 times 2. 2, 4, 8. Okay, starting up at the top again. Do I have parentheses? No. Do I have exponents? No. Do I have multiplication and division? Yes. Underline it. Write down 4 plus, what is 2 times 8? 16. And then since this is the only operation left, I do that and my answer is 20. Notice that addition was last. Notice we did some subtraction here, but we did the subtraction because it was inside parentheses. Okay. I have 2 for you to try. There are examples. See if you can work out the order of operations. Press pause, and when you resume, I will work through it with you. So pause and resume. Okay, parentheses, no. Exponents, no. Multiplication and division, yes. I have just multiplication. So I'm going to write down 2 plus, what is 5 times 2? 10. Write down the minus 1. Now, do I have parentheses? No. Exponents and roots? No. Multiplication and division? No. Addition and subtraction? Yes. I start with whichever one comes first. 2 plus 10 is 12 minus 1. This is all I have left. Answer is 11. This other example, I have 2 sets of parentheses, so I can simplify. We can work through them one at a time, or since they're separate, you could simplify all at once, but I'll do one at a time. So 2 plus 5 is 7. Since there's only one operation in there, I can do that right away. Times 2 minus 1. And see, that's why I could have written 1 down there, but it might be easier for you if you just do them separately. 7 times, the parentheses comes first, so 2 minus 1 is 1, so 7 times 1, 7. So hopefully you did those correctly. If you're having some questions or want some clarification, please let me know. Otherwise, I will see you in class.